Welcome to the course of Network Protocols. This is lecture number 16, and today we will be talking about Internet Protocol Stack, and specifically we will be discussing transport layer protocols. I'm your instructor Zeeshan Bangash. So let's move to the outlines of our today's discussion. In our today's discussion, at the very start, we will be discussing some basic terminologies. It will be a sort of review from the our previous knowledge of data communication and networks. Then we will be talking network softwares in terms of network protocols context. Then we'll be identifying the need for a layered protocol stack. Then we'll be discussing some internet protocol stack, and in the last part of our today's session we will be discussing transport layer, specifically stop and wait protocol, pipeline protocols, reliable pipeline protocols, and how to deal with the transmission errors in transport layer protocols, and some other transport protocols that are used on the internet while communication. So let's move to the basic terminology. If you can look into this diagram, so this is basically a network connecting different communicating nodes that are part of different local area networks, and they are connected to each other using the internet. So the computers that are connected to a network, we know it, they are called a host, and the connection that is made using a device, it might be a hardware or it might be a device that is connected it into a wireless medium. We call it a network interface card, or we can call it an NIC card. So this diagram shows basically that uh, that one network or composite of multi-network that comprise the internet scenario. And here in this diagram, the different computers are connected to a network, and these hosts might be communicating over the network that may be part, and they may be part of their independent networks, so that comprise the internet. So here's another diagram, and we will be discussing the a basic scenario of a post office communication, where and it's a sort of how the communication took place through internet, that the uh, that the letter that is to be, which is basically the message that first of all is generated by the sender, is packed in an envelope, and some information is added on this letter. Then, after adding some specific information, some addressing information of the sender, and also the information about the destination where this letter needs to reach, it is posted to a local inbox. This letter, after some time, reaches the local area post office, from which it is transmitted to another city, and from here it is again transmitted to that particularly city, and then it reaches to particular destination. So this is basically the same scenario which took place in the internet, how the communication took place between two remote locations that are at far distance from each other, and that passes, and the packet or that data passes through multiple hop while reaching to the destination. Here is another example, or the diagram that shows the communication between two continents. We can just look at that. There is a distance, a far distance between the sender and the receiver. So how this communication took place, that through that network interface card, this information is transmitted to the connected network, and then from here it is passed on, that data is passed on to the regional internet service provider, and from here the information is sent to the core network of that country, or particularly that continent, and from here that it is transmitted to the regional ISP of the destination continent, and from here it is again forwarded to the access network of that destination area, and then it reaches to the destination place. So it's basically how the packet from the sender moves from one hop to another hop, using a pattern towards its destination. Now we can just consider this thing, that how a person sitting in the United States is emailing some information to a person, or to a faculty member at Cohort University of Science and Technology, which is received by him in his office at the KUST main campus. So how this communication took place, so we discussed it in our previous discussion, by passing this information through different regional ISP to the core network, and then to the another regional ISP of the destination network, and then to the destination network. Now there's some basic concepts to be considered, that each cloud is represented by computers of an internet service provider. And ISP stands for Internet Service Provider. Also, it is important to consider that the ISP clouds are not directly connected to each other. However, they are connected to each other through routers, which are specific purpose computers for this purpose. Then how these routers are connected to each other? These routers knows where to send information, and a universal system of address, which is called the internet protocol, or an IP protocol address, which is a 32-bit address, is used as an addressing information with the data, which which is processed by the routers in transmitting the information or the packet toward the destination. We also know that connecting using a cable or a phone network, connection may also be made through local area network. So this is also the basic concept. And some of the hardwares that are involved in communicating a packet or a data from a sender to receiver, which we can call it as an intermediate node, comprised of some hubs and repeaters, or some bridges or switches, or some routers, and each device will be working on a specific layer. We will be talking about that in the upcoming slides. Now about the networking softwares. No, there are this is need to address some issues, like particularly the arbitrary message size, and that is of important because that can create a bottleneck. So that needs to be fixed, and the physical limitation of the network packets are also one of the main consideration. So in the protocol, or whatever protocol that is to be designed for communication, this size of that data or that message needs to be fixed. Similarly, since there's a lot of packets from the sender to the receiver traveling on different routes toward destination, so So these packets received by a receiver out of order. So again, this is the responsibility of that software who is between the sender and receiver, or that protocol, to take care of that out of delivery of that packets. Then there is another concern or the challenge that's during the communication. Some packets may reach late, or there is another concern that some packet may lose its route, or some packet may be destroyed during its communication. Another consideration is basically that while traveling towards in destination, due to some uh, challenges or to during their transmission overhead, there may be some bits that will be in errors. So bit errors in the transmission, that's again another challenge during the communication. So who take care of that protocol, which is basically comprised of different type of protocols that are taking care of these different challenges and that are put into one frame. We call it a protocol stack. So a protocol is basically a set of rules that are used to describe all of the hardware and software operation that are used to send messages from a processor A to processor B. So what is that protocol? It's basically describes the syntax, it describes the semantics, and it describes the time of communication between two devices that are communicating over a network. Now, we know from the basic knowledge in the data communication that there's a header or and a trailer to that is attached to each packet by every layer or by every particularly protocol that is processing that data. So we need a layer of protocol, and this layer basically provides good abstraction because each layer is responsible for its particularly role, and that provide a level of abstraction to another layer. So a bit of complication in terms of the development of protocol or in terms of the management of the network can be reduced. And another advantage is that why we need to layer that protocol stack is basically that it helps to simpler the understanding level, and it provides a good abstraction level as well. Now, because it's a layered architecture, so it will be easier to design, analyze, and implement. And again, it will be easy to test later on. And it also design concept is suits or family. So this is another. So while considering this layer, or we'll consider the army chain of command, that whenever there is a communication from the higher ups, say for it from a general, it is passed on to the colonel, then the colonel process it and send it to the captain, and then to a sergeant, and then to a private party, and then that is sent through the carrier to the destination unit, from which it is received again by through some private party, and then it's received by a surgeon for specific task or information, and then it is transmitted to the captain, and then onward to the colonel, and then to a general. So while this protocol stack, each level of responsibility is shared or communicated to each particularly layer. So this is again the internet stack protocol, and we can just consider that the information that is to be transmitted from the application is transmitted to the lower layer, which is the transport layer, that is transmitted again to the network layer for its some operation by that protocols of that network layer, then it's transmitted to the link layer, and then to a physical layer, and then that is transmitted to the network for onward uh, destination. Example of some of the operations in the application protocol or the upper layer from which that data generates include some protocols like the hypertext transfer protocol, which is the HTTP protocol, or the SMTP or the FTP. They basically shield applications using network from the network details. Similarly, some transport layer protocols basically breaks the message into packets and then handle these like out of order packets, and they are dealt with a reliability mechanism. Similarly, third layer, which is the network layer, is responsible for routing, and it does best effort delivery mechanisms. Then the link layer, which moves the packet using a protocol such as Ethernet, token ring, and ATM, and again the last, which is the physical layer, responsible for physical movement of the bits of the packet from one node to another. So every layer in that protocol stack have its responsibility. So this layering protocol basically helps to simplify the design of the overall communication model. Now, we already talked about the different roles of the different layers. Now, there are manufacturer groups their protocol software together into a family and give it a very good name. For example, there are some manufacturer groups like Novell Corporation, Banyan System, Apple Computers, Digital Equipment, and IBM, and the Internet Beggy. So each have given their own nice name to their protocol that they have designed. For example, for Novell Corporation, there's a protocol we called it a NetWare. Similarly, for Banyan Systems, we have Wines protocols stack. For Apple computer, we have an Apple Talk Internet protocol. For digital equipment, we have a DACnet protocol suite. For IBM, we have SNA protocol stacks. And for the Internet baggy, we have the famous TCP/IP suite, or the TCP/IP protocol stack. So the layer 5, which is basically the application layer, it sends the application specific messages to the downward layer for further processing. So the layer 4, which is basically the transport layer, it basically sends the segmentation information and to the lower layer for adding the routing information, that is the network that basically sends the packets by adding some routing or the destination network information. Then it's passed on to the layer 2, which is the data link layer that sends the frame, and at the last, which is basically the physical layer that sends the bits to the network. This is that communication model that from the sender or from the source, this application, after transmitting the data to the transport, forward it to the network layer for adding some headers. Then the packet is transmitted to the link for adding information by its protocol, and then transmitted to the physical layer for converting it to a bits, and then it is transmitted to the different intermediate nodes, which is the, just look at the hop 1 to hop 1, that may comprise that are basically the routers, switches, bridges, etc., that are between the source and the destination. And at the receiver station, the data is received by the physical layer in physical bits forms, and that's again moved in the reverse direction toward the layer 2, which is basically the link layer for getting its specific information forwarded to the upward layer, and then it reaches to the application layer. So let's talk about the today's discussion topic, that's about the transport layer. Consider the two messages. That's one message is generated by the sender. The sender sends the calls that function send and transmitted the destination address along with the message. That this message is received from the upper layer, which is the application layer, or the HTTP or the FTP or the SMTP generated that messages and is transmitted to the transport layer. And similarly, at the receiver side, there is a source address that is received by the receiver along with the messages that is copied into that variable. So the functionality of the transport layer is basically to support arbitrary messages size at the application level. Similarly, the another functionality of transporters layer is to manage the out of order delivery of the messages to make it in order delivery of messages. It also protects the application from the loss of messages. So this is another responsibility. And again, this protocol or the transport layer responsibility is also to protect the application from bit errors in the transmission. So let's look at the communication model that the sender sends a packet toward the destination, and upon receiving that packet by the destination, it sends the acknowledgement to the sender. So this is a simple communication that is the responsibility of transport layer. This RTT is basically this RTT uh, is the return travel time. Basically, it's the total time by which that packet is sent from the sender to the receiver, and then an acknowledgement is received from the receiver to the sender. Let's consider a sort of transport protocol, which is a stop wait protocol. How it works, it's very simple, that the sender sends the packets and waits for a positive acknowledgement, commonly referred to as ACK, which is known as the acknowledgement. As soon as the packet is received, recipients generate and sends an acknowledgement for that packet. Acknowledgement contains information for sender to discern unambiguously packet being acknowledged. Now the sequence number is a unique signature of each packet that is added to each packet, so that if the packets receive out of order at the destination, so that they can be numbered, and accordingly when all the packets received, so they shall be given in an order form to the destination. Now sender basically waits for a period of time called a timeout. So if within this period, if it does not hear an acknowledgement, it retransmits the packets. So it's basically sort of reliable delivery. Similarly, there's another scenario that the destination may retransmit the acknowledgement if it receives the same packet again. So we can look into it in that diagram, that while the communication from the sender, this packet, while directing towards the destination, is lost. And since this sender not receiving any acknowledgement for a particular time, which is called the timeout duration, so it will retransmit this packet 1 towards the destination, and within that timeout an acknowledgement is received. There's another scenario in which that packet is sent by the sender toward the receiver, however the acknowledgement is lost. So since that receiver is not receiving that acknowledgement and there is a timeout, the time passed for that was reserved for waiting for that acknowledgement, so that packet 1 is again transmitted to the destination, and accordingly a acknowledgement received from the destination. This RTT is basically the round trip time. It's basically the packet that is sent and the acknowledgement that is received. So here the packet 0 is sent and the packet 1 will be in waiting queue until an acknowledgement for packet 1 is received from the receiver, and then the packet 1 is transmitted. So this is the stop wait protocol. However, when we are communicating between sender and a receiver, there is some pipeline protocols that are also the category of protocols in the transport protocol suite. And there is a sort of a pipeline that is created between the sender and the destination, and the communication took place through that virtual pipeline. Just consider this, that there's a group of 3 packets that are to be sent to the receiver. So in the previous wait and stop protocol suites, the packet 2 have to wait, or the packet 1 have to wait until an acknowledgement for packet 0 received by the sender. Here all the 3 packets are sent simultaneously toward the destination. While reaching at the destination, an acknowledgement of packet 1 receives, then the acknowledgement of packet 2 and 3 and forward. Thereafter, the packet number 4, 5, 6, and 7th group is sent. So this is an example of of a reliable pipeline protocol in which a group of packets is sent, and the round trip time for that is to be analyzed, and upon the round trip time mm, uh, an acknowledgement receiving, another group of packets are sent to the destination. So here is an example of that reliable pipeline protocol in which this green shows basically the packets that are sent and are acknowledgement. This red or the maroon color basically shows the packets that are sent but that are not yet acknowledged, and this light blue color basically shows the packets that are sent in the active winters, that can be sent without waiting for any further acknowledgements. So they are ready to be sent, and these are basically those packets that cannot be sent since they are outside the active window. So this is basically a reliable pipeline protocol scenario. So how to deal with transmission errors? So there are methods need to determine if the packets are being received correctly. Example is basically checksum and the error correcting code. We already know it from the knowledge of data communication and network course. And there are another protocols that are in the literature, that are the transport protocols on the internet. We discussed these in details in the data communication and network course. So that is the TCP and the UDP. TCP is a sort of reliable protocol which works on the three-way handshake mechanism, and it is reliable and the message arrive in order and well behaved due to the self policy. However, it has some concerns related to the complexity in connection setup and tear downs at a disadvantage when mixed with unregulated flow. So no guarantees is there on delay or transmission of freight. However, UDP is a connectionless unregulated message as a datagram. So no acknowledgements or windowing mechanism is implemented in this UDP protocol. So the advantages includes that it's very simple and no frill, specially suited for environment with the low chance of packet loss and applications, and is tolerant to the packet loss. However, some drawback are the unreliability, that the message may arrive out of order, may contribute to the network congestion because of retransmission, and there's no guarantee on the delay or transmission rate. So this is basically the drawback. So some of the requirement transport protocols and the applications include that required the TCP and the UDP protocols are shown in a table. So different application that's required some transport protocol and their requirement are shown on the slide. So this is the reference from which the today's content has been taken. So you can just visit this book and for further detail, or you can just read this for getting details about this transport layer protocols. So thank you very much for patiently listening. Take care. Allah Hafiz.